Hello and welcome back to another episode of Advanced Human Gross Anatomy. Today we will be furthering a dissection that we've already started in the abdominal cavity. Specifically, we'll be looking at the abdominal organs and their circulation. If we start with the liver, remember that the liver sits just underneath the diaphragm in the upper right quadrant of the abdominal cavity. There is a bare spot right where underneath the diaphragm and the liver, and the superior liver, where there is no peritoneum, but that's just a unique little section there. Remember the falciform ligament is right in the front here. This is what adheres or helps connect and anchor the liver to the anterior abdominal wall. It also separates the right lobe from the left lobe of the liver. If we took the liver, and you can see if we took this area here and just flipped it up, right, you could see the bottom side, the underside of the liver here. So getting the diaphragmatic surface on the top here where the diaphragm would be. Here's the right lobe again and the left lobe. And then you can see underneath here we've got two more lobes here. We've got the quadrate lobe next to the gallbladder and the caudate lobe where the vena cava comes in. We've got surfaces of the diaphragm. When we talk about the diaphragm, we'll see the diaphragmatic surface, which is pretty intuitive. It's the one next to the diaphragm. We've got the visceral surface, which is the surface that's kind of on the underside facing the other abdominal organs. You can also see, if I go to this picture here, that you can see now the visceral surface more clearly on a cadaver section of a liver. Here you can see a sulcus where the vena cava would come in. That's interesting. These two holes up on top are going to be where the two hepatic veins join into the inferior vena cava, draining blood from ultimately the abdominal viscera, the intestines going into the liver for filtration, and then out through these hepatic veins into the vena cava. So after it's been filtered by the liver, it will exit here into that vena cava, which would sit right in this sulcus. You can also see on the front, if we go back to the anterior view of the liver, the falciform ligament is at the bottom of the ligamentum. The falciform ligament here, again, separating the right and the left lobes and anchoring the anterior portion of the liver to the abdominal wall. But at the bottom of the falciform ligament is the ligamentum teres, or the round ligament. And this was, remember, we talked about the umbilical vein within the womb, within development. That's what this was. And at birth, that lumen collapsed down, and now you have this ligament, this round ligament, or ligamentum teres, this rope-like ligament at the bottom of the falciform ligament. Now, this is not a course in histology, but we will talk a little bit. It's tough to talk about the liver without discussing what it does in a bit. So the liver is made up of these plates of cells, and you can see them all kind of stacked up on each other here. If you take one hexagonal shape plate of cells out, it's called a hepatic lobule. Now, the lobule is actually has corners to it at the edges of where that hexagonal shape would be, are these edges. And there are three vessels that we'll talk about at each corner of this hepatic lobule. So if we look at this drawing, it's more of a schematic here, but you can see a pie-shaped edge has been cut off. One of those corners has been cut off. But what you can see, it's just a flat part here, so it's not actually cut off here. But what you can see is what we call the portal triads. So the portal triad is three branches here. You can see them on each of the corners. It consists of a portal vein, which is bringing blood flow from the digestive organs into the liver for filtration. It consists of a hepatic artery, a branch of the hepatic artery, bringing oxygenated blood from the aorta to the liver cells. These are just cells that need their own nutrition, so they still need blood flow to those areas. And then you have branches of the bile ducts. It's those three vessels come at each of that portal triad comes at each of the corners of this hepatic lobule. So when blood from the hepatic artery and the portal vein. They kind of come in. Their flow is toward the center of this hepatic lobule. So the hepatic arteries are bringing blood flow to the cells. The portal venules here from the portal vein are bringing blood from the digestive organs, and they're going toward the middle. So they're coming from the edges, going toward the middle, percolating here through the hepatocytes toward this central vein. All of these central veins, if we go back to this section here, you can see all these central veins then are going to gather and then come out into the hepatic arteries, the right and left hepatic arteries at the back of the liver, ultimately to empty into the vena cava, the inferior vena cava. The hepatocytes are these cells that make up the hepatic lobules. And their job is to make bile. So bile is made by the hepatocytes within the liver. It flows out from these hepatic lobules to the edges of the portal triad. So they're going the opposite direction of the blood flow toward these bile ducts. So that through these tiny little canaliculi, these small connecting tubules here, connecting all of the hepatocytes, pulling that bile toward the portal triads on each side to the bile ducts. So we'll be able to follow that down, that flow of bile in a little bit here. But the liver is basically a big filter. Everything you digest, whether it be food and drink or medications, drugs, alcohol, all of it passes through the liver for kind of as a bit of a filter. So if there are toxins taken orally, the liver will take the greatest hit through that filtration system. We'll move on now to the stomach. We dissected the stomach already, so we've got the cardiac region up on top, the fundus, the body, the lesser curvature, the greater curvature of the stomach, the pyloric region, the pyloric sphincter coming into the duodenum. So these are things that we've seen a bit before, but if we look at the lesser curvature of the stomach, remember the hepatogastric ligament here is kind of this front portion, and there's also this hepatic duodenal ligament from the liver and more the kind of by the gallbladder coming down toward that toward the duodenum. If in today's dissection, if you take a blunt probe and just start kind of teasing, kind of pawing at this hepatoduodenal ligament, the connective tissue within there should separate nicely, and you'll be able to find, if I take that, here's another picture without that that hepatogastric or hepatoduodenal ligament, that lesser omentum is gone from this picture. So if you take this out, you should be able to kind of identify some of these important structures behind that hepatoduodenal ligament. The major one here is the portal vein. It's in the back. It's approximately the size of your index finger, maybe the size of your thumb. It's a big, big vein draining all of the digestive organs that we'll take a deeper look at in a little bit. You'll also find this hepatic artery proper right here, right in that hepatoduodenal ligament. And then you'll also find these bile passages. Let's just take a second to look at the bile passages. Remember that bile forms into these bile ducts at the edges of the hepatic lobules in the portal triads, or the portal triads, and they're all going to connect and kind of funnel down from the right lobe and from the left lobe, and they're going to form these right and left hepatic ducts. All right, so as it leaves the liver, that forms from the right hepatic duct and the left hepatic duct. They're going to join in together. Those right and left hepatic ducts form into the common hepatic duct. So that's this portion right through here. Now that's going to join with a duct here coming from the gallbladder called the cystic duct. And where the cystic duct joins the common hepatic duct, that becomes the common bile duct. And the common bile duct is going to flow into the duodenum, kind of with the pancreatic duct, which we'll see in a little bit, and enter into the duodenum right about here. So the right and left hepatic ducts form into the common hepatic duct. Joining with the cystic duct now becomes the common bile duct, which will ultimately end up into the duodenum. Okay, if we take the look at the gallbladder, the gallbladder's function, the gallbladder does not make bile, but it stores it, rather. It concentrates the bile. that's made from those hepatocytes within the liver. So when you eat, that bile gets released into the duodenum. And if the bile gets concentrated too much, though, within the gallbladder, concentrates, some sources say up to 12 times the concentration of what the bile is coming from the liver. If you're not eating, it will kind of back up through that common bile duct and then back up into the cystic duct and then kind of be housed and stored, allowing it to concentrate within the gallbladder. And so if it concentrates too much within the gallbladder, you might develop gallstones. I spoke with a physician years ago who told me that in his observation of pain, the three most painful things humans can experience medically might be the presence of gallstones, kidney stones, and natural childbirth. I've never had gallstones, but on that description, I don't think I'd care to. So if you investigate a little bit into the gallbladder, if you can kind of feel around, and it might feel like it's sandy, or there's some particulates within there, you feel free. You can cut into the gallbladder to investigate a little bit more. That might be interesting, but otherwise not necessary to dig into the gallbladder too much. So the bile's job is to emulsify fat. Most of what we eat is in a water base. So fat is oils, and it separates from that water base, and so it's difficult to absorb as it comes down through the stomach. So as you're absorbing something into the stomach, imagine the fat separating from that water base, and now you've got this like almost an oil slick coming through that pyloric sphincter into the small intestine. That'd be very hard to digest. So the bile helps to start break down, emulsifying that fat, breaking it down into these microscopic droplets for easier digestion within the small intestine. This might be the best shot to see the spleen as well on this picture. The spleen, again, if we did this last time too maybe, but if you take a gloved hand and reach behind the stomach, underneath the diaphragm, kind of behind the stomach, you'll be holding the spleen. It's enough to fill the palm of your hand into your fingers. It's on the left side under the diaphragm, kind of behind the stomach. Let's see, the spleen, I'm looking at the terms, the list of terms here, the gastrosplenic ligament, which Netter doesn't show here, but it's just this ligament between the spleen and the stomach, the gastrosplenic ligament. You can use a blunt probe and separate that connective tissue. And what you'll see here, you'll kind of expose some branches of the splenic artery, which we'll see in a little bit, coming from the celiac trunk, coming from the aorta, ultimately going to the spleen to supply it with nutrition. You'll also find on the spleen coming down inferiorly is the splenorenal ligament between the spleen and the left kidney. There isn't a splenorenal ligament on the right side because, well, the spleen's on the left side. So there's just that splenorenal ligament on the left side here. So two ligaments associated with the spleen. Now this is a good shot to look at the circulation of the celiac trunk. That's going to be one of the next things we look at here. But when we look at the celiac trunk, this vessel right on the abdominal aorta, it's near the, you'll also find you may find near that celiac trunk these celiac ganglion, which is a location of the thoracic splanchnics, where the post-ganglionic sympathetics come from to supply the surrounding organs, kind of within the abdominal cavity. You'll also find other thoracic and lumbar sympathetic plexuses mixing with branches of the vagus nerve for the parasympathetics, kind of through next to and by the aorta here. But let's look at the celiac trunk now with some detail. So the celiac trunk is within or behind the lesser omentum. So again, you'll have to kind of separate back through that hepatogastric ligament and find it's way down next to the aorta. You'll need to take a blunt probe and separate that connective tissue. It might be deeper than you think. What you're looking for is something that branches into three. You can kind of see three branches here, but before it does that, that celiac trunk is only about a half inch, maybe an inch long, before it branches into these three compartments here. So the three branches, let's take some time and look at these branches. The three branches are going to be the left gastric artery, which goes to the kind of that proximal portion of the lesser curvature of the stomach. So the left gastric artery here. The next branch here is the splenic artery. Splenic artery goes behind the stomach, ultimately to the spleen. You can see it kind of twists and turns here. We call that tortuous. It just turns on itself, and it can sometimes be embedded into the pancreas. Sometimes you have to kind of dig with a probe into the pancreas and kind of tear up some of that pancreas to follow it as it goes toward the spleen. And then the other one here, the next branch, is the common hepatic artery. The common hepatic artery, if we follow that down a bit, is going to it's going to bifurcate. Kind of right here, it's going to come down and split, right? If we follow it up, it becomes the hepatic proper artery. This is going to go up toward the liver. If we follow it down, it becomes the gastroduodenal artery, coming towards the duodenum. But let's continue the branch on the way up first here. So the first branch off of that hepatic proper artery is the right gastric artery. That one's going to come off and supply the other part of the lesser curvature of the stomach. So together with the left gastric that came right off the celiac trunk and the right gastric, which came off the hepatic proper artery, are going to supply the lesser curvature of the stomach. You'll see this a lot in the abdominal organs, the circulation, where more than one supply of the artery comes together to supply nutrition to that organ. So the left gastric and the right gastric come together to form that. If we follow the hepatic up a bit more, you'll see it splits into a left hepatic artery and a right hepatic artery. The left hepatic, you can see in this picture, splits a couple more times here, but then going into the right hepatic artery, comes over into the right lobe of the liver. Off of the right hepatic artery is going to be a cystic artery that comes off to supply nutrition to the gallbladder. So common hepatic splits into left and right. Right hepatic splits into the cystic artery, which goes into the gallbladder. Okay, now if we follow back down, remember the hepatic artery off of the celiac trunk comes over and it branches downward here. This we call the gastroduodenal ligament. That's going to give a branch here, which is going to follow the greater curvature of the stomach as it comes up the other way. So it's going to come around this way. That is called the right gastroepiploic artery, or another name for that would be the right gastroomental artery, because the greater omentum is right here. So gastroepiploic or gastroomental artery here. Now remember, the splenic artery comes right off of the celiac trunk as well. Tortuous, goes through the spleen, or through the pancreas on its way to the spleen behind the stomach. It's also going to give a branch off. Right here you can see this left gastroepiploic or gastroomental artery is going to join with the right gastroepiploic and then joins in with the left gastroepiploic back up to the splenic. So that circulation, again, it loops around. Multiple sources are bringing nutrition in from these areas. Now, we'll talk a little bit more in a bit here about some of the other arteries, but just to mention, the next one's down off of the aorta. Here you'll find the superior mesenteric artery, which is just kind of underneath the stomach. Which is about an inch below the celiac trunk, supplying the small intestine and the proximal part of the colon. And then there's renal arteries, which are coming off the posterior aorta, which supply nutrition to the kidneys. We'll talk about those in a later dissection. And then just lower than that, lower off the aorta, just superior to where the aorta bifurcates into the common iliac arteries, we'll see the inferior mesenteric artery, and that's going to supply blood flow to the distal half of the colon and the proximal part of the rectum. So we'll take a look at that in a little bit here. But before we talk about that, let's talk about some venous return from the abdominal viscera. So the abdominal viscera are going to drain through the liver. All these digestive organs need to drain through the liver. Remember that bile duct and that portal triad, not the bile duct, the hepatic duct, branches of that hepatic vein kind of coming up from the digestive organs have to filter through the liver before going into the vena cava. So the liver, again, it filters all of the ingested material prior to being distributed throughout the body. So again, a significant source of potential damage here if you're taking in toxins orally. So the portal vein, you can see, remember we found that in that hepatoduodenal ligament. The portal vein is formed by actually several vessels here. The big one here, one of them is called the superior mesenteric vein. Superior mesenteric vein travels along with the superior mesenteric artery, and it drains the small intestine. Here you can see portions of the small intestine, these branches coming down, these intestinal branches, bringing blood flow from the small intestine and the proximal part of the colon, so the ascending colon and the transverse colon coming in to that the superior mesenteric vein. Okay, the superior mesenteric vein. I talked about the intestinal branches, which travel in the mesentery. It's not really shown here very well, but within the mesentery, you'll find those branches flowing into that superior mesenteric vein up this way. Let's see here. The inferior mesenteric vein travels along with the inferior mesenteric artery, and that's going to drain the distal large intestines, the distal part of the transverse colon, the descending colon, and the sigmoid colon, and the proximal part of the upper part of the rectum. It's going to join, you can see here, joining with the splenic vein from the spleen, and then joining together. Most of the time that they join to get the inferior mesenteric joins the splenic. Every once in a while you'll see that the splenic and the inferior mesenteric join the portal vein individually, but most of the time you're going to see what Netter has drawn here, where this inferior mesenteric joins with this, the splenic vein, and that's going to come in to that portal vein. Here you can see some of the gastric veins as well from the stomach joining in to the portal vein as well. The portal vein, again, remember, it's about the size of your index finger. It's huge. It's maybe your thumb. It's a big, big vein in the back side of the hepatoduodenal ligament behind the hepatic artery proper. And the bile duct, common bile duct coming down. So behind there, you almost can't miss it, but I hate to say that. Okay, let's see if I can find another shot here. Here's just another picture. In this picture, Netter has kind of moved the small intestine. Here you can see more of the mesentery between those small intestines. So we could see, let's see, the superior mesenteric vein draining portions of the ascending colon and the small intestine with the intestinal branches coming up into that portal vein. Here you can see the splenic vein coming around. The inferior mesenteric isn't shown on here, but that would be joining with the splenic veins here. Here's some gastric veins from the stomach, all joining into that portal vein going into the liver. Okay, let's see what else we have here. Here's another shot. We won't be doing what Netter has drawn here, taking out the small intestine. Here you can see where all these intestinal branches have been cut that would be going to the small intestine. He's taken out the small intestine, which we're not going to do, but here you can see just a different view of that with the superior mesenteric vein draining the small intestine and the ascending, the cecum, the ascending colon, and the proximal portion of the transverse colon all coming up. Inferior mesenteric vein draining the proximal portion of the rectum, sigmoid colon, descending colon, distal portion of the transverse colon coming back up into the joining with the splenic vein into the portal vein. Here's the gastric veins. Just another view of what we've seen already. Okay, I hope that's fairly clear. Now we'll go talk about the arterial supply to these abdominal aorta, or the abdominal viscera. We've already talked about the celiac trunk, which is kind of up here. Next, we'll talk about the superior mesenteric, which you can see coming right off of here. So the superior mesenteric artery comes off of the aorta, approximately about an inch below where the celiac trunk would be. It's easier to find it by lifting the stomach up. So you can see we've kind of lifted up the stomach a bit here. It's kind of underneath behind the stomach, so it might be easier to find that there. It might be buried within the mesentery, so you can kind of take that blunt probe and start digging into until you find the vessel that kind of comes down and to the right here. That's going to be that superior mesenteric. Again, you're going to have both the artery and the vein travel together. They're next to each other. You'll have to make a distinction to tell which is which, if it's the artery or the vein here. You should be able to identify that. The artery is a little more muscularly walled than the vein, which is a little more flimsy. So hopefully you'll be able to see that. Again, the small intestine is removed from this picture, so all you can see is these cuts of these intestinal branches, which will be right here going in through the mesentery to supply blood flow to the small intestine. So during today's dissection, what I'd like you to do is almost frame the large intestine around the abdominal cavity. You're going to kind of take it out and make a big frame around it here. So you can see the cecum here with the appendix hanging down, the ascending colon, the transverse colon, the descending colon, sigmoid colon coming down into the rectum. And you can see how we've just kind of made this big frame around it. Now, gently remove the ascending colon and the descending colon from their retroperitoneal space. Remember, they are retroperitoneal. Being careful not to tear it. If it does tear, well, it's just, kind of gross, but it's not necessarily terrible. Just if it does tear, take some string. We've got string in the lab. If it tears maybe here as you're pulling it out, if it opens up a little, tie a string tightly, tie a couple knots tightly around proximal and distal to that opening, that tear, and clean out the contents of the bowel inside. And then we'll discard of that too. But just trying to do our best to we don't need to investigate the inside of the large intestine more than we need to. So hopefully we can see that. On this picture here, you should be able to see the superior mesenteric artery. I want you to be able to find this in today's dissection. It has three branches that are important to find here. The first branch coming off here, is going to be the ileocolic artery, and this is going to go to the cecum. So you can see the cecum is the proximal portion. This is where the ileum, you can see the distal part of the ileum has been cut as it joins in with the cecum here, the ileocecal valve. But this ileocolic artery is going to supply most of the cecum. The next branch up here from the bottom is going to be the right colic artery, and this is going to supply the ascending colon. And then the branch kind of up on top here is called the middle colic artery, and that's going to branch and supply the majority of the transverse colon up on top. So again, superior mesenteric comes off into these intestinal branches going into the mesentery of the small intestine. But the large intestine is going to be supplied by the ileocolic artery here. The right colic artery is going to supply, the ileocolic is going to supply the cecum. The right colic will supply and branch and give the ascending colon its nutrition. And the middle colic artery will supply the transverse colon. All right, let's look at the inferior mesenteric. Here's that bifurcation of the aorta down at the bottom where the common iliacs come out. Just about an inch or so above that, you'll find the inferior mesenteric artery. And this is going to have three branches as well. The first branch coming down here off of it is going to supply the superior rectum. It's called the superior rectal branch. So supplying the superior portion of the rectum with nutrition. There's a branch coming up over and up to the left here, coming towards the transverse colon, called the left colic artery, going to supply the rest of the transverse colon, and the descending colon is all from the left colic artery. And then all of these branches coming down off of here, supplying the sigmoid colon. We'll just call those sigmoidal branches. So you can find the first one down here is the superior rectal. You got the left colic coming up to supply the transverse colon and the descending colon, and the sigmoidal branch is coming down and supplying that sigmoid colon. So ileocolic off the superior, the mesenteric, ileocolic, right colic to the ascending colon, middle colic to the transverse. Off the inferior mesenteric, you've got the superior rectal and the left colic, giving the rest of that transverse colon and the descending colon its supply, and then the sigmoidal branch is coming off of there. Okay, now off of, when we see the arteries coming off of the aorta, oftentimes, again, you'll find these ganglia, the superior mesenteric ganglia, for instance. You'll find another place where autonomics are gathering. The sympathetics are coming from the thoracic splanchnics and the lumbar splanchnics, joining with the going to these abdominal organs. All right, so all of that viscera is being supplied by the sympathetics and parasympathetics. Parasympathetics are mixing with the sympathetics. The parasympathetics from the vagus nerve. Remember that the vagus nerve only supplies down to about the transverse colon. That's it. From the pelvic splanchnics now are going to supply the parasympathetic input to the descending colon, the sigmoid colon, the rectum, and the pelvic organs in the pelvis. And they are coming from the sacral portions of the cord. Remember that the parasympathetic innervation comes from the cranium, the brainstem, and the sacral cord, whereas the sympathetics come from the thoracic and the lumbar cords. So you'll see a bunch of those hanging around there too. So as you dissect, what's interesting, you might note those ganglions, but you're also going to see a lot of lymph nodes around here. You'll see a lot of lymph nodes within the mesentery of the small intestine. You'll see them within the omentum, the greater omentum and lesser omentum contain a lot of lymph nodes. There's also a lot of lymph nodes near the aorta. So pay attention to that. Kind of the preferred places for those are in front of the aorta. We call those pre-aortal nodes. And also to the sides of the aorta, just lateral aortic nodes. So pre-aortic nodes and lateral aortic nodes as you follow that aorta up. It seems like the celiac trunk that we talked about up here, the superior mesenteric and the inferior mesenteric arteries, all have more than their fair share of nodes. So you can kind of pay attention to where those are up and through here. Okay, let's continue our review now and look more at the duodenum. Now, last time we did a good dissection here. We ended up cutting to about here, and we opened up from the pyloric sphincter kind of down through that duodenum. And if you'll remember, we see these circular folds, these plicae circularis, the circular folds in there, and those have villi on them. They kind of give it this velvety appearance as the surface is lined with those villi. Now, if we had an electron microscope, we could even see further and see the microvilli on top of the villi on top of the plicae circularis. Remember that the small intestine is engineered to have major surface area for absorbing nutrients. So that's what we're seeing here. Now, what I want you to pay attention to, there's a bump. There's a big kind of a bulge, a bump right here with a hole in it, a bulge. And that's it's called the major duodenal papillae right here. And what you'll find is you'll find the main pancreatic duct, which is a duct coming from the pancreas that releases pancreatic juices filled with digestive enzymes made by acinar cells within the pancreas to help it with the digestion. And that's going to join with, another portion here. There's also cells within the duodenum wall itself called crypts of Lieberkühn that are creating enzymes to break down ingested items as well. So you're getting lots of things here from the pancreatic duct, the crypts of Lieberkühn within the duodenum itself, and also remember the bile duct. The common bile duct is coming in here. So where the common bile duct coming from the gallbladder and the liver ultimately joins up with the pancreatic duct, you can see here they come together, and there should be this bump here, this major duodenal papillae, which is the entrance of both that where the common bile duct and that main pancreatic duct come together. You might also see, it never mentions it here, this minor duodenal papilla. You might also find just superior to that in the duodenum an entrance of an accessory pancreatic duct here. If you don't find that, that's okay. We're not going to dig too hard to find that, but that might also be there. But I want you to try to find this major duodenal papillae. It used to be named after a person. More and more in anatomy, we're trying to get away from proper names. So now we call it the major duodenal papillae. It used to be called the ampulla of Vater, V-A-T-E-R, ampulla of Vater. Now, there's also inside, right before that ampulla, is going to be a sphincter, this kind of a muscular ring that will help control the contents from the main pancreatic duct and the common bile duct into the duodenum, called the hepatopancreatico-duodenal sphincter. That's a mouthful. It used to be called the sphincter of Oddi. That was easier to say, ODI, sphincter of Oddi. But the hepatopancreatico-duodenal sphincter coming into here. So coming from the hepatic, from the liver, from the pancreas, going into the duodenum, hepatopancreatico-duodenal sphincter. Apparently I like saying it though. When food enters into the duodenum, as from the stomach, chyme is going to come down and it's going to go through this pyloric sphincter, entering the duodenum. It's going to start giving some mechanical stimulation to that major duodenal papillae. And when that happens, it will release the secretions from the pancreatic duct and from the common bile duct into through that major duodenal papillae. As that sphincter of Oddi opens, and then you're going to start getting more of that chemical digestion. Remember, chemical digestion happens starting in the mouth with salivary amylase starting to break down carbohydrates, continues into the stomach with the gastric juices breaking down proteins, and it will continue now with all of these secretions from the bile duct and the pancreas into the duodenum, along with the crypts of Lieberkühn, more chemical digestion. Okay. If we look back here, just a review of the liver. Take note of the vena cava. That's an important structure here to find. Passes through the liver to pick up all that the liver has absorbed as it went through those hepatic lobules. As all of that nutrition goes right past that. Caudate lobe of the liver here. Where the inferior vena cava is going to be. There's two openings you can see here. Those hepatic veins flow into the vena cava, giving the vena cava all of the blood that came from the digestive organs that has been passed through the liver to filter. So, in other words, the inferior vena cava is nutrient rich. All of that blood with all of the nutrients gathered up from that portal vein system going into the liver, going directly into the once it punctures through the diaphragm, that inferior vena cava goes right into the right atrium. And so that inferior vena cava has all that nutrient-rich blood going right into the right atrium. Clinically, again, if we go back to this section here, when you damage the liver due to drug use or chronic alcoholism or various ways you can damage the liver, the hepatic lobule, this is what actually is going to die. And you're going to get bigger and bigger halos of necrotic tissue at the diseased processes here, and that's going to psoriasis of the liver happens at these portal triads. So that's what you're going to see if you're going to look at this under a scope. Just a review of the abdominal viscera. We talked about the hepatoduodenal ligament, and we talked about the things that the celiac trunk behind the hepatogastric ligament here, all part of that lesser omentum. Let's see, what else did we want to talk about here? Just another view of the pancreas. The stomach has been removed, should be here. The stomach has been cut. Here's that duodenum as it comes around. The main pancreatic duct joining with that the bile duct here, common bile duct coming down into the duodenum. I don't know if I want. Oh, here you can. That's easier to see here. The common bile duct coming into that main pancreatic duct, going into that major duodenal papillae. So that's a good review. Just as a reminder, remember that the three portions of the intestine that are retroperitoneal, the duodenum is retroperitoneal, the ascending colon and the descending colon are all retroperitoneal. So as you investigate those structures further, just be careful as you kind of remove them from their retroperitoneal space. Well, I think that'll be enough of me for today. Probably enough for you too, but enough of me for you today. Hopefully you learned something. Hopefully that was clear, and I will look forward to investigating this more with you in lab. Talk to you again.